Welcome back to College Algebra. We're going to continue finding domains of logarithmic functions. Remember, we're trying to find these algebraic more efficiently, and so let's look at another example. So this is the example I left off last time. I said go ahead and try it on your own. Hopefully this is what you understand from what we've done. Number one, the first thing is that you look at the expression inside of the logarithm. So we only look at what's inside the parentheses, which would be sorry, I didn't mean to do that, but which would be this x squared minus 4. And what we do with that x squared minus 4 is we create an inequality. We say, well, this is going to be x squared minus 4, but we want this to be positive. Logarithms cannot handle negatives, cannot handle zeros. They can only be positive. And then we have to solve this inequality. Now this means that we need to find the critical numbers. So if you remember, what that means is what we said, find critical numbers. And when they're polynomials, the critical numbers, the way you find them is you set the inequality, the thing on the left, equal to 0. So you replace the inequality sign. We're going to replace this inequality sign right here with an equal sign. And so what we're trying to solve is the following. X squared minus 4 is equal to 0. Now you've done this many, many times. You know how to factor x plus 2, x minus 2. You know that you get it equal to 0. You know that you have two answers here. Either x equals negative 2 or x equals 2. And so now you know what the critical numbers are. Now the goal is, should I put open circles or closed circles? And so the way we do this is we plug these in to the equation, into the inequality up here. So we use the inequality to figure out if we want open circles or closed circles. And so I start with negative 2 squared minus 4. Is this greater than 0? That's the question. Is it greater than 0? And so when I start doing the work, I get 4 minus 4. Is this greater than 0? Is 0 greater than 0? And the answer is no, so that means open circle. Open circle for x equals negative 2. And then we do the same, so remember that. Okay, I'm going to box it so you remember. The next thing, so now we're trying to see, what about this one? We do the same thing. We plug it into 2 squared, into the inequality up here. We plug it in there, x2 squared minus 4. Is this greater than 0? Well, that's the question. Well, we go ahead and do the work. 2 squared is 4. 4 minus 4 is greater than 0. So is 0 greater than 0? Is this true? Well, no. We know this is not true. And so again, that means that we have an open circle at x equals negative 2. All right. So I'm going to zoom out a little bit here. So at least I'm going to try to zoom out. There we go. And so now, if you remember, the next thing that we did was we created this number line. And so we look at this number line, and we know that at negative 2, we have an open circle, and that at 2, we have an open circle. And I made a slight mistake here, x equals 2. And so now I have 3 regions I need to consider. I need to consider negative infinity to negative 2, open circle, so open parentheses, negative 2 to 2, again, open circle, so parentheses, and then 2 to infinity. And I need to pick numbers in each one of these and plug them back into the inequality. I'm going to plug them back into this inequality. And so I'm going to pick here, I like to pick negative 10, I like to pick 0, and I like to pick x equals 10. So those are the 3 numbers I'm picking, and I'm plugging them in to this inequality. And so as I do this, let me scroll up here a little bit. As I do this, I just plug them in. I say, okay, well, I have to do negative 10 squared. I've got to subtract 4. And I wonder if it's greater than 0. That's the question. Is this greater than 0? And so 10 squared, the reason I picked 10 squared is I know that's 100. And I know negative times a negative is a positive. So 100 minus 4. And I don't even have to do any work. I already know that this is true. This is going to be true. It's going to be 96. And of course, 96 is bigger than 0. So we keep this region. When I try 0, 0 squared minus 4, again, I don't have to do much work because I know negative 4 is not bigger than 0. There's no way a negative is ever. And so I don't want this one. So we get rid of that one. And then finally, the last one, again, I plug it in. And as you can tell, some of you can do this really quickly. By the way, on a test, you want to show as much work as possible so that the reader understands what you're doing. You don't want to skip too many steps. But here again, you should show that it is bigger than 0, and this is also true. And so this is going to be our answer. And in fact, we have to always, and this is one of the things I want to make sure you understand, is that we are looking for the domain. And the domain means we have to solve the inequality. But what we write, to write this answer, we look at the answer that we got from the inequality, and we got two regions. We got this region and this region, so we put them together. So the domain is negative infinity to negative 2, union 2 to infinity. And it's that easy. There's really nothing else to do except for that. Okay, so let's try another example. So if you could try this one on your own, and then pause the video, and then come back and see how I solve this. Okay. In case you didn't pause, I'm back. If you did pause, I'm back right now. Again, we're going to try to find this domain. So hopefully by now you understand that what our goal is we're going to take this expression and we're going to set it greater than 0. We're going to factor. And hopefully you know it's, I think it should be this one, sorry. This is actually, I believe, -1. Sorry, I'm having technical difficulties. Here we go. Right, so let me double check. 2x and x is 2x squared, 3x minus 2x is x, and 3 times -1 is -3. Okay, so I factored this correctly. And so here, my two critical numbers, and usually what we do, and in fact I might have made a mistake here, usually we make this equal to 0, because we're trying to find the critical numbers. And so we make this equal to 0. This is our first step. And the critical numbers here are -3/2 and 1. And I have to decide if these are going to be 0 or not. So I'm going to skip some of the steps since you already know how to do this, but it turns out that we need open circles at both. Actually, you plug them in. Actually, let me go ahead and plug them in. So you plug them in and you say 2 times -3/2 squared plus -3/2 minus 3 is greater than 0. And on this right-hand side, you're going to get 0 greater than 0. How do I know you're going to get 0? Because this -3/2 is a solution to this equation. So I know it's going to be 0, so I don't have to do any work. So I already know it's going to be an open circle. So this is sort of some of the tricks. If you really understand what you're doing, you don't have to do so many things. Same thing here, x equals 1. When I plug it in, 2 times 1 squared plus 1 minus 3. This one you can actually do, but I already know that this is going to be 0 because I solved for it. And this is good. This is false again. These two things are bad, so I know it's going to be open circle. And so here's how you start learning how to skip some steps. Okay, so I know what I want. Now let's go ahead. We need to do this number line that we always do. Okay, here we go. So step number 2, I need the number line. I know that -3/2 is negative. I know that 1 is positive. And the critical numbers I always like to choose are -10, x equals 0, and x equals 10. And then we just plug them in. And by the way, our regions, -infinity to -3/2, -3/2 to 1, and then 1 to infinity. All of them, parentheses, all of them open circles. And so now we just plug and chug and hope for the best. So let's see. 2 times -10 squared plus -10 minus 3. Is this greater than 0? That's the question. So -10 squared is 100. 2 times 100 is 200. So 200 minus 10 minus 3. I know this is going to be true. If when I work this out, I know this is good. So this is a good thing. So let's keep this one. All right. What about 0? 2 times 0 squared plus 0 minus 3 is greater than 0. Well, when I work this out, I get 0, so I get -3 is bigger than 0. No, that's not true. That's definitely false. So we don't want this one. And finally, I'm going to go through the work. You should go through the work, but I think most of you eventually will. You guys are really good at finding patterns. You probably are going to assume that this is going to be true, and sure enough, it's 200 plus 10 minus 3. And that is greater than 0, and so we're going to keep this region. And so, in the end, our domain are the regions that we keep. And so, here is that there's our work. And so the domain, the regions that we kept, so it's going to be -infinity to -3/2 union 1 to infinity. So I hope this helps. By the way, on your next test, you will have to do one of these problems. Some of you missed this problem on the inequalities in your last exam, so if you can solve this domain problem on your next quiz, then you will definitely be able to earn credit on your previous exam. So make sure to study. This is an important question. I want to make sure you're good. You do well on these. This is it for logarithmic functions and finding domains. Our next video should be up shortly.